Hello and welcome back. In this video, we are going to learn the fundamental building blocks of an encryption algorithm, that is, confusion and diffusion. This is a very important and interesting topic in cryptography, as well as very perplexing. Here, I will be making the terms clear with definitions, examples, and a simple demo. Assume a person A wants to send a message to another person B over the communication network. But this network is very insecure and A fears that someone may read or tamper his message. So he wants to secure his message. The message is called the plain text. Now the encryption algorithm comes into picture. This is a special algorithm which converts the plain text to a form that cannot be understood by a third party. This text is called the ciphertext, which is transmitted over the communication network to the receiver B. The concept of confusion and diffusion in the encryption algorithm was introduced by Claude Shannon, a cryptographer known as the father of information theory. The confusion process in the encryption algorithm obscures the relationship between the plain text and the ciphertext. This means that the message is changed to a form in such a way that it is hard to find the relationship between the plain text and the ciphertext. This is achieved by the substitution method. An example of substitution method is a Caesar cipher, where every letter in the message is replaced by the next third character in the English alphabets. The diffusion process of the encryption algorithm reduces the redundancy in the plain text. This is performed by the transposition or the permutation method. It is achieved by rearranging the letters of the plain text. For building a strong cipher, the confusion and diffusion process is mixed in a single cipher in different combinations. This is called the product cipher. The substitution permutation or the SP network is a block cipher that has layers of substitution and permutation in its algorithm. Now let us consider the example of data encryption standard, which is one of the most popular computer encryption algorithm. It is incorporated with the SP network. Here, it achieves the confusion process with the S box and the diffusion process with the P box. DES performs confusion with the S box. Here you can see an example of the S box. This substitutes a 6-bit data with a 4-bit data. The input of the 6 bits is divided into two parts to get the row index and the column index. The combination of the first and the last bit gives the row number, and the remaining middle 4 bits gives the column number. Let's say the 6-bit input is 101000. For finding the row, the first and the last bit is considered, so we get 10, which is equal to 2. To get the column index, the middle 4 bits is chosen. Hence we get 0100, which is equal to 4. So, the second row and the fourth column in the X box results in 13, which is circled in red. You will be now interested to see a demo. You can see an 8 by 8 matrix. Each cell has a color and a value on it. The color denotes its location and the value on it is its data. Now when I press the substitution button, note that each value is replaced by a new value, but the color of the cell remains the same. This is a demo of confusion which is performed by substitution. Let's see the P box or the permutation box. Here the data is shuffled to a different location. The first table is the input data and the second table shows the shuffled data. Here is another fascinating demo. Now note that when I press the permutation button, the cell location changes, which is clear with the shuffling of the different colors. You might also observe that the value on each color cell remains same. Hence, in permutation, the location of the cell is shuffled, but the data is preserved. This is how diffusion is performed. Now you would have understood what is confusion and diffusion with the example and demo. You would have also understood the role played by confusion and diffusion in building a strong cipher. Thank you for watching.